All right, this is where we left off in class. Um, we're going to go ahead and do example 3.3, which says finding the equation of a tangent line. And to find the equation of a tangent line, we need the slope of the tangent, which I'm going to run you through this process. And then we need to use point slope form to figure out the equation of the line of the tangent. Now the function is f of x equals 1 over x at x equal 2. So I've gone ahead and written it on this screen here. Okay, so that's the function. It's 1 over x. And just to give you a sense of what we're looking at, this function, as x gets smaller, this gets larger, and as x gets smaller or larger, smaller negative, it gets larger negative. So it runs something like this. And we're interested in figuring out what the slope is of the tangent line at 2. So assuming, let me see if I could do a little bit better job on those. Maybe I can use one of these lines, and let's go ahead and color it blue. So just, to give you an idea there, that's what we're interested in figuring out, is not just the slope of that line, but also the equation of that line. So first of all, we definitely need the slope of that tangent line, which is found by getting the limit of f of x minus f of, say, a, we'll call it a, and then x minus a as x approaches a. And so in this case, we're looking at the limit of 1 over x minus, now we have to identify a, in this case is 2. And so this is 1 over 2, and then x minus 2. So we're going to use a little trick here, because obviously I can't just directly plug in the 2. What I'm going to do is multiply, and I'll put this in brackets because this is all inside the limit. I'm going to multiply by 2x over 2x, which is obviously equal to 1. And so what that leads me to is multiplying the 2x over here and then 2x over here. And we really won't do a whole lot on the bottom. We'll leave them separate. But what it allows me to do in the numerator, more importantly, is to write the limit of 2x over x minus 2x over 2, because this value really ends up just going to the numerator. And then I've got x minus 2 times 2x. So I've dealt with both of these now as x approaches 2. And then we can cancel those x's and cancel out the 2's. And we're left with the limit of brackets 2 minus x over x minus 2 times 2x as x goes to 2. And we can simplify a little further. This is a limit of brackets minus parentheses x minus 2. Those can be made to swap positions. And I've got x minus 2 and 2x. as x goes to 2. And I know I'm running out of space, but those cancel. And I've got the limit as x approaches 2 of minus 1 over 2x. And I can now directly plug in the 2, and that's negative 1/4. And just to confirm, notice that this is a negative line, so it should have a negative slope. Okay, now we still have a little bit of work to do. Let's see if we can accomplish that here in this box. Let me erase a little bit of that to give me a little more space, because I was asked to find the equation of the tangent line. So then I know the slope, which is great. The point that I'm interested in is x is 2. That just comes from the given. And then f of 2, plug in a 2 here. So this is going to be 1/2. So using something called the point slope form, we do y minus 1/2 is equal to m times x minus 2. I'm just using these 2 points. And let me come over here. Y minus 1/2 is equal to negative 1/4 x plus 1/2. And the final answer, I think I can wrap it all up and move that negative 1/2 over. So that becomes negative 1/4 x plus 1, because if I add a 1/2 to both sides, I get a 1. And so therefore, that would be my final answer. What I'm looking for is the slope of the tangent line. Not the slope of the tangent line, but the equation of the tangent line is what I'm looking for.